Okay, folks, section 4.3, multiplying monomials. Now, before we get started with that, we want to go over the rules of exponents for products of powers. What? I don't know. Here's what I want you to write. Okay? For the moment, just rules of exponents. I'm going to give you one of them. Okay? When I have a base, when I have two numbers that I'm multiplying and they have the same base, all I have to do is add their exponents. For instance, x squared times x to the 5th is equal to x to the 7th. Just add them. Okay? 3 squared times 3 to the 3rd is equal to 3 to the 5th. Okay? There's a guy by the name of John Napier, right? I think he was Scottish. Was he Scottish? I have to check into that. And he came up with something called logarithms. Okay? And the idea behind the logarithms, and here was the whole thing. The whole thing is, do you see this is a multiplication problem? Right? It's a to the m times a to the n. We're multiplying, right? But what do we actually, what's the math that we do to get the answer, Kyle?
It's like a times however many times m is.
Okay, but wait, Kyle, let me go back over here. Look at this. Do you agree this is a multiplication problem? 3 squared times 3 cubed? Did we multiply to get our answer?
Yeah.
Did we?
No.
No, what did we do?
We just added.
Logarithms took multiplication and changed it to addition, which in the 1700s, 1800s, that's a lot easier than trying to multiply huge numbers, right? If you could change them so that they had the same base, all you had to do was add their exponents. Add their exponents. And he came up with these huge long log tables, logarithmic tables, so that you knew that 21 was equal to 10 to the 1.7316 or something like that. Okay? You knew that that's what 10 equaled. That's not right. It's more like 1.1316, something like that. Okay? And if you knew that 47 was equal to 10 to the 1.4971, do I need to multiply 21 and 47? No. I can add their exponents. And that gives me 10 to the, 2 point something, 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 something. I just look up in the log table and it tells me what that is. So it changed multiplying long things, big numbers, or tiny little numbers, and they just made it addition. They wouldn't even change it. They just keep it like this. That's fine, done. I don't have to worry about it. Okay? It made doing the computation of math a lot easier. Okay? We're not doing any of this. You will get to logarithms in advanced algebra. You'll do that. Okay? And graph them and that sort of thing. But that's the idea behind it. Does that make sense? Okay, good. Well, good. Nice job. All right? So, example number 1. I'm sorry. I would have made it harder if I could have made it harder, but I can't. Dylan, x cubed times x to the 5th is what? X to the 8th. Done. Okay, thank you, Dylan. Well done. 3 plus 5 is 8. Okay? Now, a little more challenging because our answer is an odd number. Clay, b to the 7th times b to the 4th?
Yes, sir.
What is it?
28.
No.
Oh, wait, you gotta add. Oh my gosh.
You okay?
Sorry about that.
What is it?
B to the 11.
b to the 11th. All right. Everybody happy there? You weren't even listening, were you?
I was
He
listening.
was listening, he just forgot it. I mean, that was at least 42 seconds ago. So don't worry about it. All right, are we okay? Everybody good there? All right, let's look at the next one.